the function value given to you is a monotonically increasing function. So let us look quickly about that problem so you can practice that. Okay. Okay, so as a practice, we can try this. Given now a monotonically increasing function, that means as n increases, the function value increases, something like n square over 10,000. We want to use the binary search algorithm to find the largest value of n for which f of n is less than a target. So you could again try starting from n equals 1. So if n equals 1, f of n is going to be 1 over 10,000. That's going to be 0.001. Now as n increases, this is going to be 4 over 10,000. So it's going to be 0.002. Sorry, 4. So what we want to find is the largest value of n for which f of n is less than 0.01. So as you see, as n increases, the function value keeps increasing. So it could be, say, n is some, I'm just guessing, so 50, let it make it, like n is 100, so that's going to be 100 square divided by, say, 10,000. So 100 square is also 10,000. So the function value becomes 1. So you see, as n increases, f of n increases. So for lower values of n, the function value is less than the target. But when n is 100, the function value becomes greater than the target. So our threshold value, which is the largest value for n, is lying somewhere in this range of 1 to 100. So you can go through a similar process, but here you have to define the left index and right index carefully. So we want to find the largest value of n for which f of n is less than a target, right? So let us define then the left index to be the value of n for which the function value of the left index is going to be, like here what you have, less than the target. Okay, and then the right index is the value of n for which the function value of the right index is greater than or equal to the target. So it could be like 1 like this, or it could be on 0.01. So but what we want is the value of largest value of n for which the function value is less than the target. So for this problem, you keep doing the iterations like this, and the final answer is going to be the latest value of whatever the left index you end up with. Okay, so it need not be 14, but I'm just using this as an example. So your answer is going to be based on the left index for this problem. Okay, because that's how we define the invariant. Okay, is that clear? So try it out as a practice. Any question? Okay, so let me save this.